dear conference participants. My presentation is about the gravity measurements in Latvia territorial waters. And there is also a colleague from Riga Technical University, Lyubova Shulyakova. We made this presentation, and I myself, I am from Faculty of Civil and Mechanical Engineering and the Institute of Civil Engineering. It's a previous department of geomatics is included into this department. And to remind the definition of geodesy, geodesy is the earth science which studies the Earth's size and shape and gravity field. And even due to the gravity field, we have asteroids and all this is falling down and here too. And in this Balmar Grau project, I would, sorry, all will be, not all, but many information in Latvian, because it's also important for local people to know the gravity field studies. And I will explain maybe the main in the English, and there you see the project partners which participate in previous project, rather small, and the main task was the Baltic Sea chart datum. It necessary for ships to use geoid model for together with GNSS measurements to have heights and to know that distance from ship to the bottom of the sea. And it's very necessary when you plan the routes, and it's save a lot of fuel. This is also, and how it's located to that between the partners. We use this from 1960s, 70s, 80s, that previous old gravity measurements, and we also plan a new ones into the project. And there is a project partners, many partners around the Baltic Sea and also from the Germany. And that was to study old and to validate the old data, and also to look for archives if there is some data which is missing still. And there is all gravity data is into Nordic Geodetic Commission database, and the Nordic Geodetic database physically is on the servers in Denmark. And there is a region of the Nordic Geodetic Commission. And also the green one, as you see, is included into this. And it's the data, there will be more about our region. Our region is also into the Nordic database. There is on the terrestrial data. And also we have some data in Russia from the maps. Digitized, and there is on the sea, and there is a gap, and the gap into this project was we found the data in this Latvian archives, and we digitized and we implemented to the database. And that is how it looks at with the new. This is at points which is. The gap is no more. We fill in the data. And what is interesting that this data in this area is bottom gravity measurements on the bottom of the sea. And it was a huge work. And for example, the one ship would be able to measure that is a guess, but only during 1 year it's such territory it's possible to survey. And there is at the coastline of Latvia measurements, it's from 1990s, which was already after our independence, a survey was done by the company from St. Petersburg on the contract. And there is the numbers of the different sources, which is into the database, because it's registered. Every who is give a data, it will be a source is registered. And in this Baumar Grau project, it's already we finish in 2024. We were a leading partner and associate partners. Also, this is Latvian Marine Administration, and this is Latvian Geospatial Information Agency. And through Latvian Geospatial Information Agency, we got the ships where we set up the marine gravimeters, and we did this gravity surveys. And there is during that recognition, we already start to look for a ship in 2023. And this is Latvian ship Christian Dāls. It's also good, but the problem was that this ship is doing survey only on the ship routes where its ships goes, and we needed to cover all territory, and then it would be additional expenses. Such like Christian Dāls, the expenses for 1 day run is around 4,000 euros, and then it's need a lot of money to run. And there is a marine gravimeter, what we set it up in. This is in office, and but just to see the size. And marine gravimeter is from Sweden, and we in the project, because they also are partners in the project, and it is possible to use the gravimeter free of charge in this our project. And there is about the location where we should put the marine gravimeters, and in the next pictures will be also that dive size of this gravimeters. It's a size like 56, 70, and 64 centimeters, and there is additional computers and oops, and but that can be placed a little bit back, but this is important that the place how much is necessary to find on the boat. And there I put one picture. It's very important to have separate GNSS antenna. It's needed for timing, and also to know that movement or speed of the ship, because it's also need to compensate about this inertial. And before the turning and after the turning, there is some time, some data which need to be cut it out, because it's the speed should be 10 knots, something that's the best optimum. Not faster, not slower, but it's optimum on the same speed. And such a gravimeter is available only in Sweden and also in Germany. And for example, if somebody knows that possibilities to place it such, then it's still offer from Germany that they can give us free of charge a gravimeter to use in Latvia. Just found the vessel where to put it. But as I said, it's most expensive to find a ship, and they call a buggy pack when they put on the ships like Tallinn, Helsinki. You just place it, and then it will go 10 times in both directions, and you get just one line, very good data, because just it will be And there is, it was permitted to, it's from a real ship where we place a gravimeter. It was allowed to make the photo because there is restrictions. And there is a harbor of Liepāja, as many of these observations taken from Liepāja harbor, and that's why I decided to put. But this Christian Dao was possible to use only in these routes, certain routes, not in all territory. And the measurements was done in the May and in June until the 23 of June, and after in 24 it was work with the data adjustment, and now we come to the roots. That is what we have here is milligauss this crossovers in this maximum distance. When it's yellow, it's good, and there is something is need to be checked and verified, and it complemented database which we call to the previous database was the NKG 2015. It was all the time was compared to with the previous datas, and there is all territorial waters of Latvia was covered with very dense survey. Only the Gulf is needed still in the future to more measurements, for example. And yeah, and there is Gabriel Strukowski, who is the main person in our computations, and that was that if there's a standard deviation in this crossing points was less than 0.9 milligauss, then we accept the results. And if not, then we delete the data. And there is, before we had the planning with the coastal guard vessel, but in the previous slide, there is a realization. Only that the scale is maybe better in this picture. And it was connected in Liepāja and in Riga to the ground reference points. When the ship comes to the harbor, because this is a relative gravimeter, you need to connect to the absolute sites, and it's done in Liepāja and Riga.
Okay, you have 1 minute. Or 0 minutes.
And now what is in like the future, we are a research and development grant. We have together with Maritime Special, with Maritime Academy about maritime special planning according to the international requirements on the Kurzeme coast. And in this, there is on the Varam website is possible to found the marine special planning, and we want to implement in this planning one more layer, which will be the gravity data of this Interreg project. And there is already interest of the planners for a usage of such data. And yeah, thank you for your attention.